Good morning and welcome to all attendees to this webinar today on the subject of innovations and solutions for solar PV and battery energy storage systems. My name is Chris Yelland, Managing Director at EE Business Intelligence, and I will be your host at this webinar, signed in from Johannesburg. Welcome also to our presenters, who will be introduced to you in due course. I will share a link with you now on the Zoom chat facility where you can download the presenter biographies. So please take a look at the chat facility and click on the link and you can see the presenter biographies. And a big welcome to you, the attendees, for your interest and participation. This webinar is hosted by EE Business Intelligence. I'd like to acknowledge and thank T Good, the Heralds Group, Solar Boost, TruePoint, and Fibon for their valued support for this webinar and for the great work that they do in this field. Some 1,650 delegates have registered to attend this webinar to hear what the presenters have to say on the subject. This attests to the relevance of the subject matter being covered, as well as to the stature of the presenters. So may I thank you, the presenters, up front for your participation and for the time and effort that you've put into your presentations. Please do note that this webinar is being recorded, and links to view the webinar on demand and to download all the presentations will be made available tomorrow morning at 9 o'clock to all those who registered to attend, as well as publicly. I'll be sending out an email with a report back with the video links and the presenter links. Colleagues, this webinar explores some of the latest developments, product and service offerings that are shaping the solar PV and battery energy storage landscape in the region, as the demand for reliable, sustainable, and cost-effective energy grows. The webinar unpacks innovations in locally manufactured SF6-free switchgear and prefabricated packaged substations, which form balance of plant and smart BES solutions for solar PV and hybrid renewable energy plants. The webinar also explores the latest residential, commercial, and industrial sector solar PV, inverter, and battery energy storage developments, products, and features for enhanced performance, durability, efficiency, safety, and ease of installation, whilst reducing installation times and costs. The webinar also covers locally developed ICT and AI, artificial intelligence solutions to optimize asset management, performance, predictive maintenance, fault finding, energy security, and electricity costs for solar PV and battery energy storage installations. Finally, the webinar explores innovative asset financing and ownership options that help speed up project deployment, extend financing terms, and maximize monthly savings while reducing financing and operational costs. So the program for today has been widely circulated, but I'm going to share now a link on this chat facility to download the program, which I have sent previously, but is being shared again now on the Zoom chat facility. So please take a look again, and you'll see a link which you can click on and download the program for the day. So we have a number of expert presenters who will be given 4 25-minute slots to make their presentations. And in between, we'll have a 10-minute comfort break. Then I'll wrap up with an overview of the presentations and some insights of my own. After this, we've set aside about 30 minutes for our presenters to answer just some of your questions in an open discussion and Q&A session. While the presentation is in progress, please do send your questions on the Zoom Q&A text facility, not on the chat facility, on the Q&A text facility. You may also put up your hands to ask questions verbally, and if we've got time, we'll get to those. So without further ado, I want to now introduce to you our first two presenters, and they are Anton de Swart, and he is the Battery Storage Business Development Manager, as well as Gey Botha, who's the Sales Manager, both of them from T Good Africa. So if I may just read out quickly their bios. Anton started in the solar industry in 2008, doing residential, CNI, and utility scale projects. He completed extensive training on solar plants in Germany. He was certified as an inverter engineer and trainer by Keiko New Energy, and has since personally managed the installation and commissioning of more than 70 megawatts of grid-tied solar PV systems. I won't go further, but his bio has been shared with you. Gey, on the other hand, brings decades of experience in electrical engineering and business development. He started as an electrician with a Wyman's license and later earned a national technical diploma in electrical and mechanical engineering and a higher diploma in business management. He's held roles in product manager, proposals engineer, business development manager, specializing in prefabricated substations, transformers, and medium voltage switchgear. Again, I'm not going to read his full bio. You've got that. I've shared it with you. So without further ado, I'm going to call on Gey to come forward and begin the presentation, and then he will be followed by Anton, after, about half the presentation. So over to you, Gey.
Good morning, everyone. Teagood just wants to point out the difference between SF6 gas and dry air insulated switchgear. As you know, we're in the renewable energy market space where everything is green. So Teagood's virtual component portfolio is that we can offer, as an OEM, original equipment manufacturer, a full range of products contributing to your solutions, from 3.3 kV up to 132 kV. We've got different facilities of manufacturing. Our SF6 free range is manufactured in Germany and Switzerland, and then our other products are in China and with a head office in Hong Kong, and we also got branches across the globe. So from the traditional switchgear on the left-hand side, which is SF6 switchgear, Teagood has now moved into a new venture of a range on the right-hand side, which is SF6 free switchgear. And the reason for that is there is significant dangers when it comes to SF6 gas, because when the arc is quenching, it creates bioproducts, and that's harmful to the environment. So it's a potent greenhouse gas, which is toxic and can cause aspirations as well, excitations. So for the environmental impact, greenhouse is a global warming gas, which is very harmful to the environment, as we know, and it stays in the atmosphere for very, very long times. It also poses very big health risk as to ventilation, crucial ventilation where the gas is exposed to the atmosphere. So the risks continue, and the risk that could cause is aspirations due to the product being exposed to. It can also cause skin and eye irritations, and even up to frostbites. So it's very important for handling safety concerns that it is being detected and there is leakage detection available when you do use SF6 gas. So what is the alternatives in the industry? And that's where Teagood has moved into new ventures now, that we are using dry air insulation as a medium in our switchgear. And this has low impact on the environment, or actually no impact on the environment. It's very safe and it's cost effective for the environment. For the environmental benefits, it reduces the greenhouse gas emissions in the atmosphere, and there's no toxic byproducts being created while using this dry air. Dry air also aligns with the environmental regulations that we need to move into. As you know, the whole of Europe needs to move away from SF6 gas by 2030, and we are also slowly following that trend, providing green energy solutions. So for safety advantages, the electrical breakdown, dry air probably stables the electrical environment. It lowers the toxicity in the atmosphere, and it simplifies the handling of the product. For cost and operational benefits, it lowers your operational cost due to lower maintenance, as well as the need for less equipment needed on site. It also causes easier maintenance, and it simplifies the process of maintaining equipment. Dry air solutions can be more modular and easier to expand or adapt to changing needs. For the regulatory compliance, it's aligned with the environmental regulations as well. So on our portfolio, Teagut specializes in prefabricated substations, where it's much easier to transport the equipment to site after the whole substation has been built, making it faster for the renewable industry to keep up and running and also improve their production cost. On our air-insulated switchgear, the new range that Teagut has brought out, we can offer up to 40.5 kV air-insulated switchgear rated at 2,500 amps, 31.5 kV. For the smaller units coming from the IPP substation, Teagut also has an RMU range, which is 40.5 kV, a 24 kV unit, and as well as a 12 kV unit. All of the units are rated up to 1250 amp, 31.5 kV. Now, if we go to the 40.5 kV switchgear, you'll find that it's broken down in different components. So you will have a low voltage compartment for your relay, and then you will have a pressure relief channel should there be any pressure built up in the unit itself. And then a clean air tank, which is SF6-free, obviously, the operating mechanism compartment, and then your cable compartment. Anton, I will hand over to you now to take the presentation further.
Good morning, I'm Anton de Swart. I'm the Business Development Manager for BES system for Teagut, for utility scale BES projects as used in solar and wind projects, mining projects, and microgrids. Here we have examples of a 3 and a 5 megawatt liquid cooled BES system housed in a 20-foot container. The 3 megawatt hour BES.
Are you still there, Anton? Can you change your slide?
Can you hear me? Can you hear me?
Yes, we can hear you. Please speak up.
I say here we have example of 3 and a 5 megawatt hour liquid cooled BES system housed in a 20-foot container. The 3 megawatt hour BES have a total of 80 battery packs with access doors on both sides for maintenance purposes, and have 2 chillers to keep the battery cool at all times. On the right hand side top, we've got the 5 megawatt hour BES that have a total of 48 battery packs in 6 racks with access doors on one side and have 1 chiller to keep the batteries cool. Here is an example of a 314 amp hour 0.5C prismatic lithium iron phosphate cell. This cell is tested by the manufacturers to pass around 62 safety tests in order to get all the international IEC, UL, and UN certifications. This 314 amp hour cell have a typical cycle life of more than 6,000 cycles at the 80% state of health. On the top left, you've got a 52 cell battery pack. It is used in a 0.5C 3 megawatt hour BES container, and the 104 cell battery pack is used in a 0.25 and a 0.5C 5 megawatt hour BES container. It is very important to note the weight of these liquid cooled batteries, and may vary between 310 kilograms and up to 685 kilograms per battery pack. So for on-site maintenance purposes, you will need to use a forklift to replace a battery if needed. There is 28 temperature sensors between the cells. And in the battery pack, the liquid cooling ensures optimal temperature balancing between the cells. For maintenance purposes, the front access method is used. Here is an example of how the liquid cooled battery pack is built. At the bottom is your liquid cooling plate, and then heating paste is applied to the plate, and the battery cell blocks is then mounted on top of it. All temperature sensor cables is connected to the BMU on the front panel. Your front panel houses the following: the high voltage connectors, the battery management unit, pressure release valve, communication cables, plug-in composite probe, that is a modular sensor or monitoring unit integrated into the battery system BMS. Here is an example of a 5 MWh base container configuration with 6 racks consisting of 8 batteries each. Each rack has its own power distribution unit at the bottom. The high voltage battery cables is connected to the PDU, power distribution unit, and the PCS, high voltage connectors, is connected to the electrical high voltage distribution panel in the electrical room. The PDU also have external AC power supply, communication interfaces, and status and warning lights. With these thermal images, you can see how efficient liquid cooling technology is. The temperature is controlled to stay between 20 and 21 degrees Celsius at all times. The maximum temperature difference between the batteries in the racks is below 3 degrees Celsius. With liquid cooling technology, the base power consumption is reduced to 40% compared to an air cooling system, and it is suitable for energy storage systems with large energy density and heat generation. The battery management system has the following main functions: the real-time monitoring, cell balancing, passive or active, protection mechanisms, battery state estimations, system architecture, data logging and diagnostics, safety and compliance, optimization, and lifecycle management. A BES is equipped with an automatic fire extinguishing system to meet the requirements of the NFPA 855. The BES must comply with the UL 9540 certification and the UL 9540-A testing method. The system includes cabin level detection, fire controller, emergency start and stop buttons, audible and visual alarms, gas firing extinguishing devices, gas spray indicators, etc. The system also has aerosol sprinkle pipelines and a reserved water fire protection interface that is not mandatory but optional. The plug-in composite probe, form part of the BMS to monitor and manage various functions of your battery pack. Here is an example of the technical specification of a 0.5C, 1C, and a 1C 3 MWh liquid cooled BES. It must comply to all the international standards as listed on the left-hand side. Cell ratings is 280 amp hours for both the 0.5C and the 1C configuration. The DC voltage is up to 1500 volt. Your PCS voltages is up to 690 volt. Your step-up transformer that we will use with the system is an oil-immersed step-up transformer that will step up your 0.69 kV voltage up to 11, 22 or 33 kV. System parameters. Here it's important to note the weight of the system for logistical purposes. So you will see on your 3 MWh, the weight is 36 tons, and it can be difficult in Africa, in remote areas, to transport this type of weight. Next screen, you've got your 5 MW BES system. There you've got the typical 0.5C and a 0.25C BES system, which I call the 2-hour and 4-hour battery system. Here the cells that is used is a 314 amp hour, capacity is 5 MW. DC voltage is up to 1500 volt. Your cells or your batteries have got 104 cells per battery, 48 batteries. We're using, for thermal management, using smart liquid cooling and heating for the battery system. For fire protection, we use combustible gas detection, emergency ventilation, and aerosol firefighting and water firefighting. You'll see the round trip efficiencies here of the two configurations. 0.5C is 93% and 0.25C is 94%, due to the fact that different cells is used. On the AC parameter side, there you can see on your 0.5C base system, you can connect 4 1.25 megawatt PCSs, and on the 0.25C, you can connect 2 1.25 megawatt PCSs. AC voltage of the PCS is 690 volt, and it will step the voltage on the step-up transformer from 690 volts to 11, 22, or 33 kV. It's 20-foot containers, both the 3 megawatt and the 5 megawatt hour container. The 5 megawatt hour container weight is 41 tons. Both systems operating temperature rate is minus 30 degrees to plus 50 degrees Celsius. The relative humidity is from 0 to 100%. The ingress protection rating is IP55 C4 as a standard, but C5 is optional for coastal regions. Your maximum altitude is 5,000 meters, but it will start derating above 2,000 meters. We use Modbus protocol to the external devices. It complies with all the international certifications. So BES have a typical 5-year warranty that's extendable to 10, 15, and 20 years. Current LFP cells that they use in most BES systems today is 280 and 314 amp hour. In 2025, major LFP manufacturers are developing cells with a capacity exceeding 500 amp hour, with some reaching over 1000 amp hour per cell. There is a link that I have included that you can read more about it. And you can see in the table who is the manufacturers that providing or manufacturing this new big cells. What is next in BES systems? Capacities from more than 6.2 megawatt hour is in the pipeline in 20-foot containers, and up to 12.5 megawatt hour in 30-foot containers, like for example the SunGrow 3.0 system. I thank you for the opportunity to present.
Well, thank you very much, Gey and Anton. You've kept within your time limits. That's absolutely fantastic. And I know that there are a lot of questions that you will see on the text Q&A text facility. So please, if I can ask you, both Gey and Anton, to take a look at the Q&As and see if you can answer some of those questions in text form. We're going to have a Q&A session at the end of all of this, where we're going to be dealing with some of the themes that have arisen from you, the presenters. But it would be very helpful if you, the presenters, could answer as many of the text questions as you are able to do, because we get a lot of questions and it's impossible to handle them all during the half an hour Q&A session. So thanks for your help, and thanks for some really interesting insights on the latest developments in SF6 free switchgear for containerized substations, which really are, I think, an interesting approach to speed up the deployment of solar PV systems and battery energy storage systems in the industrial and utility space. So a really interesting set of presentations there from T. Good. And with that, we're going to move on to our next presenter. If I can ask, if I can introduce you now to Hein Herold. Hein, if you can switch on your camera and your microphone and share your presentation as I introduce you. Hein is the CEO of the Herold Group, a company that started from humble beginnings and has now grown to have a national footprint, and is said to be South Africa's largest importer and distributor of electrical products, including solar PV modules, inverters, batteries, and battery energy storage components and systems, mainly for the residential, commercial, and industrial sectors. He has extensive experience in the wholesale and retail industry with a strong background in growth and management. He's recognized as a speaker and expert in his field, actively engaging with industry trends and challenges, particularly in renewable energy and project management. In 2024, Hein was awarded the title CEO of the Year at the Energy Box Solar Energy Storage Future South Africa 2024 event. So it's really great to have you on board here, Hein, and we're looking forward to your presentation and to hear more about your solutions and the latest trends that you are seeing emerging in this field, in the residential, commercial, and perhaps even the industrial sectors. Over to you, Hein.
Thank you, Chris. And it's an honor to be here with you guys today. I really appreciate the time. And I really appreciate everybody that's joining this webinar with us today. So just a little bit of background about Harold's. Like Chris mentioned, we are importer and distributor for majority of electrical and solar PV equipment. We've got branches across the country, all the way from Mbombela right down to Cape Town, Port Elizabeth, and Durban. Our branches all have distribution warehouses and stock major components that I'll get to in a few minutes. Purely, here's a short slide about our vision and our mission. Ultimately, the idea is we want to be able to give clean, reliable energy access to everybody. Doesn't matter who you are. Ultimately, at the end of the day, everybody has got the right to clean, renewable, and sustainable energy, and our vision is to see that happen for everybody in South Africa. We are also authorized distributors for major brands. I am not going to touch on all of them. Some of our major brands include Sungrow, Solar Edge, SIG Energy, ICO, JA, and Trina Solar. Today, I am here to present more about SIG Energy and new innovations that is happening in the field when it comes to C&I and residential, as well as industrial and utility battery energy storage systems. So just a short recap about SIG Energy and who they are. SIG Energy, the visionary behind this is a man called Tony Zhu. Tony is created the #1 global PV brand in the world, Huawei. He was with Huawei since 1999 up until 2020. This is a position that's normally held for 3 years. He maintained the record for 8 years for being the #1 inverter brand and shipment in the world. He ran their smart PV business since 2010 all the way up until 2020. In 2020, he went over and he was the president of Huawei's AI business, where he created the #1 AI computing chips framework in China. And in 2022, he founded and started a company called SIG Energy. SIG Energy is, although they're a very brand new company on the block, they are backed by major funders and are doing their public IPO within the next year. The current president of SIG Energy has also been part of Huawei for 15 years. The head of industrial design has been with Huawei for 30 years. The chief marketing officer has built the #1 brand in solar and AI, has also moved over to SIG Energy. The head of hardware and R&D has been in Huawei since their first gen inverter. And the head of software and R&D has also been there for the past 20 years. The company now boasts employees of over 2,000 people, of which 50% of them sits inside R&D. They do quite extensive research and development into this battery energy storage as well as the solar PV sector. And they currently have 420 patents that they have applied for. Their product comes in a modular stackable form and consists of 2 product lines that they are currently running. The majority of the business is mainly built on software and making sure that the software and hardware integrates, as we are moving into a sector where energy optimization becomes way more important. One of the projects that I'll speak to you about later is just a testimonial of a 20 megawatt hour fully battery storage plant that was built. But all of their products are IP66. This 20 megawatt hour plant was constructed or installed in 10 days and commissioned over a period of 2 days. They've also ranked as the #1 stackable market share since for Q1 to Q3 in 2024, being the #1 stackable solution inside the market. So the product comes in two forms, which is #1 of them is Sag and Store. Sag and Store is your residential and light commercial product. This comes as a stack that the inverter will always be at the top. These inverters range in single phase from 5 kilowatts all the way up to 12 kilowatts, and in three phase from 12 kilowatts all the way up to 30 kilowatt. We recently helped EPC complete a project building a 2.4 megawatt, 4.8 megawatt hour system with a 0 millisecond changeover from grid to off grid at a cable factory in South Africa using these stackable solutions and making use of the 25 kilowatt inverter systems. The energy controller is sitting at the top, measures a size of 300 by 260, and that is whether it is a 5 kilowatt single phase all the way up to 30 kilowatt three-phase inverter. The inverter stays exactly the same. These can also be overpaneled by 200% on the single phase units and 160% on the three-phase systems. It's a full DC optimized system, which means you can charge the batteries as well as supply the load. And the inverter size is not limiting the energy throughput on the DC side. When it comes to the batteries, you can stack up to 6 modules per stack, and the batteries come in a 5, 6, 8, and 9 kilowatt hour model. And these can also be mixed and matched, old and new, different sizes, as well as the inverters can also be paralleled in any configuration you want. So if you need 40 kilowatts of inverter power, you can use a 15 and a 25 or 2x20s or a 12 and a 30. This does not matter. You can mix and match them as you like to build the perfect scalable system that you need. Inside the system, there's also leading safety protection. So there's PV disconnect protection, arc fault protection up to 500 meters, DC ground fault protection inside the energy gateway that does the 0 millisecond changeover. So this is UPS grade changeover. There's also grid fault protection and DC bus protection. Inside your battery packs, they come with 280 amp hour or 314 amp hour cells up to 32 volts. Each battery has a battery optimizer that then boosts the voltage up to 600 and 800 volts. That means that all the batteries operate separate from each other. Inside the battery modules, there is a temperature resistance pads on the outside with a battery heater for cold conditions. They can operate from -20 all the way to 60 degrees ambient temperature. There's full temperature sensors across the entire battery module, aerogel insulation pads between each one of them, a decompression valve should you have any gas buildup on the inside, as well as an internal fire extinguishing module inside every single pack itself. This means that you have fire protection on every pack level. What makes this quite different from standard battery solutions, if you've got your traditional parallel connected, you have a battery added at a later stage. You've got 2 older batteries and 1 new battery. What happens is your older batteries will cause the cask effect, which will drain the energy from the newer battery down to the older one. If you're looking at a series connected system, this also is the same thing, that you have the cask effect because the voltages tends to run to where the lowest voltage is. You also have to always get your packs to the same voltage when you want to add a battery pack. With the energy system, each battery is on an island by itself, which means each one of them operates individually. This means that in the future, if you need to replace a battery or add another battery, it doesn't matter if the new cells in the battery came from a different supplier and the capacity is different. You can add it at any state of charge and any state of health, and the system will manage that battery by itself. This also means that if you should have a failure, you also only have an isolation of a single battery module. This then makes sure that the rest of the battery system is always working, and you only lose whatever that battery size is on your outage. SIGEN Stack, which is the CNI and industrial solution, now comes between a 50, 60, 80, 100, and 110 kilowatt HYB inverter with a battery stack that can stack up to 240 kilowatt hours per unit, which can give you a 1C or half C type design. Each one of these battery modules are 12 kilowatt hours. They stack on top of each other and then connect to the inverter. Up to 300 kilowatts, you can parallel. If you need anything up to 10 megawatts, there is a gateway that then handles all of the switchover. Also, if you tie into medium voltage, this can be done via a transformer. The battery safety that's built into SIGEN Stack is a 6-layer protection. It covers all of the same ones from the previous gen, which is the light commercial section, but it also has a built-in smoke sensor. This means that if you look at traditional systems, you either have battery safety protection at a pack level, which is 200 kilowatt hours, or even at a container level, which is 5 megawatt hours. With this system, you have a battery safety protection per 12 kilowatt hours. This makes sure that the battery runs at the optimal safety level, and if you should have any issues, that is always isolated to just one component and not the entire system. The whole SIG Energy architecture runs off an AI-enhanced MySIGEN app as well as SIGEN Cloud. This means that every single thing inside the system is controlled via AI. So AI optimizes your battery usage. It looks at various things like weather patterns. It also has a look at what your current usage patterns are. So if you are in a residential dwelling, what it'll do is when you switch the AI on, it starts learning what your consumption patterns are, and then make sure that you have the lowest cost energy available at any given time that you are using it. Also has a plug-in to the ESP app, which then preps the battery should you be using it as a arbitrage or time of use saving method. The moment load shedding or any power outages is announced, the battery will charge itself automatically to make sure that you do not run without power. It will also not aggressively charge the battery to the full capacity. It will only charge for whatever stage or battery would be needed, and it would charge at the rate that makes sure that the battery is always protected and not being overcharged. When you look at the SIGEN AI, it will always determine what will be happening next. So if you look at the buying and selling prices based on the battery SOC, it will tell you that during the morning early hours, there is no solar power generation. The battery discharges to meet the low demand. It will also give you a future forecast and let you know exactly what it will be doing moving forward into the next 12 to 24 hours of the day. When you are using the AI, you can also use it as an assistant. The AI assistant does not just solve, it solves, it does not respond. So GPT 4.0 integration is built into the SIGEN app. So any installer or any user can just ask the AI, maybe investigate why the battery is not charging at the current time. First, it's necessary to confirm the basic device information, and then it will query the operation status and then reply based on the system's analysis operating status. Your system is set into maximize self-consumption mode. At present, the load power consumption exceeds the PV generation power, so there is no excess electricity available to charge the battery. The AI does not just manage the battery, it also manages your PV smartly. So when you are able to export or sell, or have got high and low cell tariffs, it automatically makes sure that number one, electricity security is always number one priority. The second priority will be to maximize the savings of your system. So the whole idea about the system has been designed to make sure that you get the maximum return on your investment. One of the great features that they've just built into the V3 app is you can see where your energy is coming from and where it is going. This is a full touch illustration where you can see each inverter, each source, the EV-DC charger, which is number one or the first of its kind V2X ready, which means that the EV-DC charger in a residential system with a 6 kilowatt inverter can charge up to 25 kilowatt DC power when it is connected to battery and PV. You can also see use your EV vehicle, and multiple brands like BYD, BMW, Porsche, Mercedes have all approved the SigEnergy DC EV charger to be bi-directional, which means you can, if you run out of battery power, you can pull off your electric vehicle standing in the garage and supply your home. You can also export your battery power to the grid if your country or your grid code allows that, like they're currently doing in Australia. This illustration then shows you on the left-hand side where your sources of power was. So solar, third inverter, battery, EV-DC, generator, and grid. And then on the right-hand side, it shows you where that energy went. So if you touch on the solar portion, it'll show you the 54 kilowatts hours of solar production went, 8.212 went to the battery, 11.9 went to load, and 43 was exported to the grid. Once you touch on the load side, on the other side, it'll show you where that load power came from, what came from solar, what came from battery, and then what came from grid. It also has a separation of the energy that is inside the battery at that stage. So should you have run a generator for an hour, it'll accumulate what the generator cost is that's put inside the battery. If you charge with the grid for 3 hours, it will then accumulate what those costs were, and then if you charge with PV. So your battery will have in its full capacity of 100%, stating that 60% was from PV, 20% was from grid, and 20% was from generator. You can also then decide which portion of this energy you want to use first. Obviously, the lowest cost energy would want to be used. So if you happen to have charged your battery with the generator, you would want to use that portion last. Although it's blended inside the battery, it knows that 20% of the battery current state of charge has come from generator. And if that energy was built in at, let's say, a rate of 10 Rand a kilowatt hour, the system will then automatically switch to grid using the grid power, which is cheaper than the battery power that you have stored, and it will keep that for the absolute necessity. This is the project that I spoke about earlier. This project is one of two 20 megawatt hour projects in Bulgaria. It was built with 90 by 110 kilowatt hybrid inverters and 90 by 240 kilowatt SiGen stack batteries. As I mentioned, the stack was built within 10 days, as you see it on the picture below, and commissioning to 2 days. If you look at residential or smaller commercial systems, the AI helps you with the commissioning. So when you commission the site, you literally open the app, you scan the barcode, and it runs a full diagnostic check. If you have somewhere down the line maybe swapped around a positive and a negative on your PV connection, or you've got a battery connection that is not properly done, the system will first run a full diagnostic check, and when it has picked up that there's a fault, it will reply to you on the assistant saying that if you check inverter number 7, battery connection is not done properly. If you check on inverter number 9, MPPT number 1, the PV positive and negative has been swapped around. So the system won't switch on if there's any fault on the system. It will first run a full diagnostic check and then only allow you to commission. As I mentioned, commissioning normally takes for up to a megawatt, roughly between 5 to 10 minutes, as it does all of the commissioning itself. One of the great features that SIG Energy's new HYB inverters have is they have automatic phase rotation, which means that if you've connected maybe 3 inverters in the wrong sequence, it does automatic phase sequencing and will switch those phase sequences the right way around. One of the major accomplishments was a 500-meter arc fault detection. So up to 500 meters, it can detect any arc fault and then let you know exactly where the arc fault is. When it picks up an arc fault, it will shut off that MPPT on that inverter, which still means that you do not lose the entire inverter's production, you only lose the MPPT's production. If you have a battery issue on any stack, it also just cuts out that single module. So when it comes to redundancy, this is first in class. One of the great features about this is you do not need any heavy lifting equipment like cranes and forklifts. This entire system can be installed with a 2-man person, as every single component is modular. It connects and plugs in with no external battery connections, fuses, or any DC disconnects needed. If you need to get any more information on this, I have a team that is available at Harold's. I have just put the last slide up that shows my email address, Jared Nadia, who is our sales manager for SIG Energy, and our marketing manager, Anik Robertson. If you need any information, I will answer all the questions inside the Q&A. My team is also on here to respond to any questions that might be needed, but do not hesitate to reach out of us. And Chris, I really thank you for your time and the chance to present here today. Like I said, when it comes to this product, there's quite a lot that we can do. It was a real hard one for me to cram an 84-page slide or presentation into the few slides that we have today. But should you need any more information, please do not hesitate to reach out to myself and our team. Thank you so much. Back to you, Chris.
Thank you very much, Hein. Yeah, absolutely interesting to hear the latest state-of-the-art developments. And you can see this convergence with the ICT, the information and communication technology, converging with power technologies. You see this trend towards modularity, which was covered also in our first presentation, where one looks at modular switchgear, modular substations, prefabricated, and the goal seems to me to speed up, and Hein touched on this, how to install and commission these systems fast, because time is money. And I think you covered admirably, Hein, the latest technologies that are coming out in the inverter and battery energy storage systems that you supply, which was my brief to you, to cover, what is on the edge. And you've chosen to tell us about the SIG Energy system, which is cutting edge stuff. And of course, there are developments like this taking place around the world. And it's really interesting to see what is really happening at the state of the art of battery energy storage and inverter technology. So thank you very much to you, Hein, and to Harold's group for that. So, ladies and gentlemen, I'm now going to call a comfort break for 10 minutes. And it's now 10:47. So can I suggest that we get back at 11 o'clock sharp? That's just over 10 minutes. We're running well on time. It's fantastic to be on time like this. And let's have a cup of coffee and a stretch of the legs. And if I can ask Ian to put on the holding slide for the comfort break. So this is what you will see while we're having the comfort break. And if I can ask you to be back here at 11 o'clock sharp, when we will have our next 2 presentation slots It's been absolutely fascinating. First two presentation slots, and I can assure you that the next two are going to be equally fascinating, covering various aspects of the solar PV and BES technology, including ICT, artificial intelligence, optimization of these systems, which is really the name of the game. How to get the best value out of your system, the most savings, the highest reliability, the most energy, highest availability, energy security, obviously, is one of the major reasons why people install these systems. So to maximize savings, to maximize energy security, to maximize reliability, and lastly, to maximize safety. We've heard a lot today about safety that is built into these systems, from whether it's switchgear and substations through to solar inverters with with arc fault detection and circuit interruption, with batteries, with built-in fire protection systems. Safety is critical in the modern world, and distinguishes is one of the critical success factors of any product going forward. So it's been a really interesting discussion on technology so far, and more of it to come. And we'll see you back at 11 o'clock sharp. Thank you. Well, ladies and gentlemen, I'm back again. It's 11 o'clock, and we're going to continue with our webinar. And it's been a great start. Thank you, presenters, the first batch of presenters, for great presentations. Really interesting, what you're doing and the state of the art. It's now my pleasure to introduce to you our third set of speakers, two speakers, in fact. And I'm going to introduce you to both now and then hand over to them. So the first is Bianca Bazzoni. Bianca is the Managing Director of TruePoint Africa. And then also Paul de Goede, who's the Chief Technical Officer of Solar Boost. So let me start with Bianca. She's a founder and MD of the African office of TruePoint, which is a consulting firm helping clients achieve sustainable improvement by unlocking the potential of their organizations and their people. Her consulting career started at McKinsey and continued at Yellowwood Venture Investment. She's held multiple leadership positions, and that's given Bianca unique insights into the complex ecosystem of business, government, and social sectors, with deep experience at innovative startups, having led a enterprise incubator and kickstarted a social innovative franchise focused on increasing renewable energy adoption. She's got a business science honors degree and an MBA degree from the University of Cape Town, and a master's degree in sustainability from Bologna Business School in Italy. On the other hand, Paul is the co-founder and CTO, Chief Technical Officer of Solar Boost, where he leads the development of advanced solar monitoring and management technology, driving growth and adoption of the Solar Boost platform in the energy sector. Paul's an accomplished software engineer with 30 years experience in software architecture, data-driven platforms, and developing customer applications, including his time at Microsoft. He brings experience from his previous leadership roles at Portfolio Metrics, at Petrichor, and the Knowledge Factory, and has a robust skill set including business analysis, management, consulting, strategy, software development, and more. He's got a BSc honors degree in computer science from the great University of Cape Town. So with that, I'm going to now call on Bianca to give her presentation before she hands over to Paul. Over to you, Bianca.
Great. Thank you so much, Chris. And really, thank you so much to all the presenters who've already shared their great innovations. As Chris said, I'm the founding and managing director of TruePoint South Africa. We're a management consulting firm who've been operating for the past 20 years, based now in Johannesburg, but Boston, Toronto, and London. And effectively, we come around leaders to partner with them to deliver their success. And we're here today with our partner, Solar Boost, who we're partnering with to grow their business. For example, we've partnered specifically to secure some EU funding, which we've just got good news that we've secured that, which is a very exciting kickoff to that partnership. And today I'm going to share a bit about some of our other partnership work. And specifically, it was around accelerating renewable adoption in South Africa. And this was in partnership with the University of Cape Town, Bologna Business School in Italy, and then a local brains trust. And effectively, that kind of highlights how we work. We look at the expertise that sits in the different businesses. We curate an expert brains trust to understand what the problem or the opportunity is, and then we work together to solve the problem and opportunity so we can move to action. And specifically what we're going to share today is actually, while there has been amazing momentum in moving forward renewable energy adoption, there have been some blockers and challenges when we look from the consumer side, specifically from the business decision maker side. Why is it sometimes hard for business decision makers to say yes? Why are proposals sitting on desks for 6 months, 12 months, 18 months? And what can we do about it? So what we did, because we very multi-sector focused, we brought in these great partners. We said, okay, let's go chat to the business decision makers. So we chatted to a range from CEOs, CFOs, COOs, sustainability leads, across over 20 business decision makers in South Africa, across listed and unlisted. We also chatted to over 10 enabling. So most of the banks, association, industry experts such as Chris, to really understand what is happening. And what we found across the way is that basically the customer journey is a multi-year, multi-proposal process. This isn't I make one decision as a business decision maker and it's done, which is quite unusual when you look at some of the other decisions they need to make. So this loop you're seeing with the blue circles, those are decision points, and this whole cycle actually happens multiple times when people adopt renewable energy. So what we were able to understand from these multiple conversations is, what do people consider and think through if you think about that road to adoption? Because we all want more adoption. There are these amazing innovations that are happening. We need more adoption to have more renewable energy and more sustainable energy as we look to South Africa as a whole. And some of the good news that we found is that customers are actively engaging with renewable energy sources. This is very different globally. Our US colleagues are not experiencing that. They're finding one of the hardest things is to start the conversation. But the reality is, in our context, people are engaged, but there are internal business priorities. And it's important, but not always important enough. So, for example, when they're making decisions, if you have to be the top 3 to get CapEx investment in that business, it's often sitting at 4 and 5. When they're thinking about exploring solutions, there's a huge amount of complexity around the technical solutions. And as was shared by some of our previous presenters, there's some amazing work happening, but it's very technical and very detailed. This also means they're experiencing, from their perspective, lots of noise in the marketplace from suppliers. Commercials remain a massive and important decision. And as I'm sure you've all experienced, decision makers are different across customers. It can range from CEO, CFO, sustainability lead, technical lead. And what we actually found when looking at where businesses are sitting when you think about adoption is that businesses are mainly sitting in the risk space. There's exciting opportunity to move to optimize an opportunity, but they're mainly in the risk. So what do we mean by that? If we have a look at financial costs in terms of what are the implications of adopting renewable energy versus level of adoption, we found that most of the business are playing in this risk space. They're kind of dabbing their toe in, they're kind of figuring it out. Only a few have managed to go, I know exactly what I want, this is my pathway, and this is I'm going to first optimize and then have opportunity. And opportunity really is actually, now you've seen a revenue source or potentially increase in business value because what you're doing. This is what we think is a massive, massive play for everyone in the renewable energy space. How do we translate and shift everyone from risk to opportunity? Because it is often around matching what the solutions are to actually what the business priorities on the business. And we find there's a lot of friction and mismatch, that through better communication, better translation, and understanding of the business needs, we can actually ease adoption. So I suppose the question everyone would ask is then, well, what can we do about it if we're going to actually find this opportunity space? And there are 3 lenses you can apply to this. If you're thinking about the supplier, we need to start shifting from here's our solution, take it, to be a full trusted advisor. So you can't just say, this is our solution, it's great, it's going to save you money. Show them how it's going to fit into their other full energy solution against their business priorities. We have to also remove friction. We were seeing a huge amount of friction in all of the suppliers' processes, whether it's an NDA, whether it's a 3 to 5 steps that could be down to 2 steps. Every time you add in an extra step, you're making it harder for business decision makers to say yes. Share success. We know this is a unique position. Every business is actually bespoke and different. So share where you've been successful that is applicable so they can see that they can, with certainty, opt into the solution. And the other big thing we found, because decision-making is so relationship and actually personal based, at the moment, it's quite a high-risk decision. So how do you de-risk the decision across the business? And this is what we saw actually in one of the biggest differences between the businesses who were operating in the risk space versus the optimize and opportunity space. The optimize and opportunity, the CEOs and the decision makers were going, well, it's obvious. Of course we're doing that. That just makes complete sense. Whereas everyone still playing in the risk space was saying, I don't know what to do. I'm still uncertain. I'm just not sure this is best for us. And we do feel there's a huge amount that can happen just through how we are translating our solutions. When we think about from the lens of business leaders and business decision makers, we need to get comfortable. This is a multi-year, multi-solution process. It's not something we can just make one call and off we go. But the big thing we found is that there's money on the table now. And by not making decisions, by letting proposals sit on a desk for 6 months, 12 months, 18 months, you're losing out. And no one wants to be in that position where you have more risk lens than an opportunity lens, where you can actually be adding positive value to your business. And finally, from a systems perspective, when we think overall, there is an openness to support a just system, and we just need to keep driving momentum and pushing our policy and regulatory change. So I think, as we leave and as I hand over to Paul, we really think there's an opportunity to shift how we're communicating to our business decision makers and how we're coming around them to really help them move forward. Because we all want a situation in South Africa where we've got massively increased renewable adoption. So I'll now hand you over to Paul, and they'll share how they're playing in the optimize energy space.
Thank you very much, Bianca, for that. And yes, as she alluded, they've managed to harness some serious funding from the EU to Solar Boost. And they've brought a lot, I think, to the table in driving this process. And I'm very excited that it is succeeding and that I'm being drawn in as some kind of to use some of my insights in this project too. So congratulations, Bianca and team. And now we're going to go to Paul. I've introduced Paul. His bio has been shared, and it's a pleasure now to hand over to Paul from Solar Boost to tell you something about their platform and their technologies and their solutions, and what is the cutting edge of ICT that is happening in this space in South Africa itself. Over to you, Paul.
Bianca. And also fellow presenters. It's quite an honor to be presenting with this audience. And lastly to the attendees, good morning and thanks for attending. So obviously a lot of context around Solar Boost and our history has been given, so I'm not going to go into that. I'm really going to jump into what we see as some innovation within the solar and BES space. So I think firstly to start off, we talk about the 3 M's, so it's the monitor, manage, and maximize. And I think just to talk to all of those points. I mean, the monitor is really about getting real-time data to ensure you've got system health and you can manage. You can choose directions based on that data that you're getting. I think we have to understand that the volume of data is completely non-trivial. If you're reporting data at second or sub-minute intervals across hundreds, if not thousands, of metrics, every minute, every day, you're generating millions of data points. And what do you actually do with that data, right? Like, how do you use that to manage your system or maximize what you get out of it? And I think the manage part is really about looking at that data and having different actions that you base off that analytics from those data. And then maximize is really taking the monitoring, the managing part, and also your external environment in terms of tariffs and expected loads and things like that on your system to drive kind of peak efficiency and ultimately maximize the ROI of your system. So seeing the unseen, the case for kind of smarter monitoring. So, that whole adage about silence is golden and no news is good news is definitely not the case in the solar PV and BES space. You really want to actually make sure that you're getting indicators that are supporting the fact that the system's performing as you expect. And where that's not the case, you want to get given a very directioned and focused area that you need to look at. And whilst we all kind of experience a lot of the positives of the solar boom of 2020 to 2024, ultimately there was a huge demand that was driving that. And because of that demand, the focus of the industry was really around the rush to install and move on to the next project. And as a result, because the demand was so high and the ability to supply was so low, the monitoring and maximizing of these various systems was mostly an afterthought. What we typically see in the industry is that I would say kind of 80% plus of residential small and medium C&I systems are monitored reactively, right? So there's no proactive monitoring on it. There's no advanced analytics on it. And the challenge with that, and of that, sometimes when we talk about monitoring reactively, it's often the owner or the end customer who's actually highlighting issues. And as a result, months can go by with a system not performing as it should be, or potentially situations where the assets in those systems are not actually being protected. So there's kind of four big areas to kind of focus on with regards to monitoring. So obviously the one is kind of production and the solar PV system. The other is really your asset protection, and that's really around like how do we manage ensure our inverters last, they're within warranties, our batteries are likewise they last and within warranties, and they're performing such that we can get the most ROI out of them. And then kind of back to the rands and cents about imports and exports, making sure that all of this translates into financial terms, which actually maximizes the ROI. And feeding into that is the alerts and different pieces of information the system is giving you. And this is really where kind of there is a big area where the industry can add a lot more value here. Typically in kind of the residential and C&I space, a lot of the monitoring is done by other inverter platforms or third-party loggers. And whilst they are great in that they provide a lot of data, the issue with that is that there's no intelligence or there's no advanced analytics applied to that data. So, I think it's if you look at kind of an EPC trying to log into various platforms and pull different pieces of data, and it's almost impossible for them to understand kind of correlations between different pieces of data or long-term patterns in different pieces of data. There's really no way for them to do that, unless they're going to kind of create analytical platforms, which is not really their strong suit. Their EPCs are focused on installing kit and making sure that kit runs as they would like it to do. And also, when you look at a manual verification step, like it's very expensive. It takes a lot of time and effort for someone to sit there and do it, and more importantly, it's also quite error prone. So on the back of that, the case for a smarter monitoring environment within these sectors is pretty much a no-brainer. We need to have tools and products that can support EPCs to do this analysis and the legwork, such that they actually can maximize the ROI on those systems. So to give you a couple of kind of examples, so things that we've kind of seen over the last kind of 6 to 8 months is, one example is kind of systems that are incorrectly exporting based on either hardware issues or firmware or whatever it may be. We've seen kind of over 1,300 plants that were exporting to the grid incorrectly, and in the majority of those cases, those customers are probably double paying for that export. Another kind of example of like this monitoring is lost production, where you've got issues on particular strings on the MPPT. And, in the last, 8 months, you've seen at least 400 plants that have kind of had that. And, if you kind of pair this, the incorrect export and lost PV, and the back of the envelope estimation, you can about 10 million rands worth of unnecessary costs for the end customers. And, back to what Bianca was saying, this risk that people see in this uncertainty around making decisions around buying, fairly expensive or spending capex on fairly expensive solar systems, if we can kind of give them certainty around the fact that they are going to produce and they are going to get the ROI they want, those decisions become a lot easier. Another example of what we're seeing is things like battery temperatures running outside of manufacturer warranty specifications. So we've had 1,000 plants, we've got those batteries running out of those specifications. And the challenge with that is obviously, you could be voiding your warranty. So when the supplier interrogates the BMS and sees that it's been running out of its spec, they might not honor warranties, but also you've got an asset which you are effectively shortening the lifespan of. And we all know that temperature is the battery killer. It's a massive issue for them. And now you've invested this money and you effectively are running away, which you are compromising the ROI of that asset. I think the second is really moving on from kind of the basic kind of challenges where you're losing or you're reducing ROI in the system. Performance blindness is real. There's not a lot of tools or analytics which can tell you that your system is performing exactly how you expect, and that's taking into account load patterns, it's taking into account tariffs, weather, etc., etc. There's a whole bunch of external factors that go into that performance as well. So, kind of key metrics, obviously there's the import, export, and the production. Then, we've kind of coined this like lost PV term, which is really around, are you efficiently using your battery to maximize your PV and hybrid systems? And then the time of use arbitrage, in certain circumstances can be significant based on what the load patterns are and the deltas between the peak and off-peak periods are. Lastly, the other thing to kind of think about is really around balancing of the correctly balanced system. So a system which is either over-paneled, over-batteried, you really are leaving ROI on the table with that system. If you had a correctly balanced system, then that you can ensure that you've maximized your ROI. So just some kind of case studies to concretize like these concepts. So I mean, we optimize around 2,000 plants at the moment, kind of battery and tariff arbitrage. And we'd estimate over, 500,000 rands of savings in June alone. So when you accumulate that up, you're looking at about 6 million rand of the savings across those 2,000 plants. Then talking to kind of balance or sizing of plants correctly, particularly in the residential and small CNI space, and probably even in the mid CNI space, the ability to size a system really requires, at least 6 months, ideally 12 months of baseline data to understand how, that site consumes electricity, what their load patterns are. But also what's important is that changes over time. It's not a static thing which you've done once and it's correct. So really, as load patterns change, and potentially as tariffs change, we've seen like the latest tariffs in terms of the timing and the rate differentials change. Your sizing of your system, your balancing your system, is actually quite a dynamic concept. So it's something you should be looking at, every 6 to 12 months to confirm that your system is still fit for purpose, or whether it's actually there's a good ROI case to be made for upgrading certain parts of it. So we've got a product called Size Pro, which effectively does this, which looks at historic load patterns and various external factors, like weather, etc. And then it can give you an indication of what the correct sizing of a plant should be, given that the actual data that you're running. So it's effectively like a digital twin, is kind of one of the terms people use for it, where we create a digital twin of your plant and then we simulate different scenarios with that plant. And our Size Pro product has generated hundreds of reports which indicate that certain either battery or PV upgrades would have an ROI of less than 5 years, which is a very compelling financial case to be made for that upgrade. I think a sip of water. Then, kind of allied to this is the case for better battery optimizations. So, batteries and hybrid systems are typically between 20 and 40% of the total cost of the system. Historically, because of energy insecurity, these assets were seen as a protection asset, a biosecurity asset. And I think now with the stabilization of our grid, there's a lot more focus on how do we actually sweat that asset. So we've spent whatever it is, between 100 and R500,000 worth on batteries. Are we actually getting the most out of those batteries? And if you look at things like tariff arbitrage, if you've got the right tariff delta and the right load profiles, we are seeing paybacks of upgrades to battery packs in less than 2 years, which is almost a slam dunk. It's a no-brainer from a decision-making process. And we have the additional benefit of providing a lot of stability to the grid in terms of helping lowering those peaks. So one kind of example to kind of concretize this is Retirement Village, which effectively moving on to the correct tariff and utilizing our tariff arbitrage, which takes into account load, weather, etc. We expect their savings at the end of the year to be in excess of 395,000 Rand. To concretize that to the cost of the service, you're looking at kind of paying that battery back in under 3 years. I mean, it's a very compelling financial case to be made for this. And I think just broadly talking about the market, and this ties into the kind of first slide, we have come from an install-focused environment, and I think the industry, and they really are shifting, and we're seeing a lot of shift, which is awesome. It's good for the end consumers, but they're really need to shift towards kind of SLAs or proactive maintenance. And historically, there hasn't been enough effort put into maximizing the ROIs and ensuring warranties are valid and ensuring the assets are actually, have the ROI that we expect. And this is a constantly moving target. So I think that's kind of a common thread throughout of this. All of these aspects are dynamic. They change over time. It's not a do it once and you fit for purpose. It really is something you need to continually do it. And what we'd like to see is really an environment where system owners and decision makers, to Bianca's point, whether it's with the help of a trusted advisor, really demand, those 3 M's, the monitor, manage, and maximize. They should be treating this asset like any other asset in their business that they want to really get the most out of. I think in terms of what I spoke about earlier around the load shedding protection, that's something that really public perception needs to change. They really need to kind of understand this asset and what they've got, what they can do with it. And to Bianca's point, there isn't enough knowledge in business owners to kind of really even understand what services they should be demanding. And we don't really have enough kind of technology to actually enable the EPC to provide these kinds of services to the end customers or system owners. And I think just in closing, just to tie back, the 3 M's are critical. Everyone should be have this top of mind. And we do feel that there are a large number of solar system owners out there, particularly in the resi and small CNI and medium CNI space, that are underserviced and really they aren't getting the ROI that we want. And there's a big transparency and education piece which we're working with 2Point on to really elevate the understanding within the end customers. And the great thing about that is if we can maximize the ROI of those decisions to actually continue this massive push into solar and hybrid systems will only get better. Thanks very much for your time. And I'll hand over to Chris.
Yeah, thanks, Paul. It's really wonderful to see this level of effort taking place here in South Africa to really maximize the return on assets. And as you pointed out, these 3 M's, measure, maximize, and manage, and really looking at asset management carefully, because as you pointed out, if you use these assets wrongly, temperature and cycling, etc., wrong charging, cycling more than you have to, you're actually damaging your assets. And so there are ways by monitoring and controlling to actually extend the asset life and to maximize the savings, maximize your energy security, and finally, ultimately, your return on investment. And that's what we need. We need to move away from just installing these things because we had load shedding, which was energy security, the driver, to now a more nuanced look at the asset and the return on investment and the savings and the life of the asset as the drivers going forward. And ultimately, the driver also becomes, certainly in the commercial and the industrial space and the corporate space, the decarbonization benefits, because companies need to decarbonize. There are threats that they face if they don't decarbonize. So it all kind of works together, and to see this optimization is really interesting, and Solar Boost is at the forefront of this as a South African company. So great to hear from you, Paul. So we're now going to move on to our last set of 2 presenters from the company Fibon. And I'm going to be introducing you to Avesh Padiachi, who's the Chief Executive Officer, and to Jason Hogan, who's the Head of Business Development, both from the Fibon Group. So Avesh is the Group CEO of Fibon. It's a company providing long-term energy, water, and finance solutions in Africa through power purchase agreements, wheeled power, outright purchase, and carbon offsetting. Avesh started his career in corporate law, a lawyer, and while employed at Weber Wenzel, working on a West African hydro project, he saw how sustainable power could be generated by private sector interests and then provided to a national utility. So Avesh then left this legal profession in 2012 to immerse himself in renewable energy, and this was the genesis of his business. So in 2017, he was named Future Energy Leader by the World Energy Council and was chosen for the FEL 100 program, which is a global community of young professionals, 100 young professionals committed to shaping the global energy future. Jason, on the other hand, is the Head of Business Development and the Senior Manager Special Projects, where he delivers tailored solutions reflecting the company's entrepreneurial spirit and its commitment to innovation. His mandate spans strategic initiatives, energy supply, trade, management, and he helps clients unlock the full value of sustainable energy. Look, I'm not going to read out his bio fully. I've shared it with you. It's in the document that I put on the chat program. So let's get on with the business, and I'm going to ask Avesh to open the presentation, and over to you, Avesh.
Good morning, everyone. I'm Avesh Pediachi, the CEO of Fibon. Thank you for joining us today, and a special thanks to Chris for bringing together a lineup of industry experts. We at Fibon are proud to be part of this conversation. I'm joined by Jason Hogan, our head of business development, who will unpack case studies of financing solar battery storage in key sectors in South Africa as we go through the presentation. So perhaps an intro to Fibon. For over a decade, Fibon has been the financing engine behind the meter energy projects in South Africa. And in the past 2 years, we've been powering wheeling arrangements, financing water projects, and driving carbon credit solutions through our carbon arm, Primary Carbon. Within the Fibon finance team, we have been delivering bespoke funding and carbon credit frameworks that really unlock annuity revenue stream for EPCs, fast track project timelines, and add value to your customers. So I founded Fibon really with the objective of increasing access to power at an affordable cost. Because I really fundamentally believe that it's the driver of economic growth. And in doing so, we help businesses in South Africa to thrive. So with that in mind, let me dive into the financing landscape that's shaping South Africa's renewable energy future. So I'm going to talk about the financing solutions available in the market, what we're seeing around both solar and battery storage. But I think it's important to understand that this discussion must be had amidst the backdrop of the changes that we are seeing in the market. And this is firstly the market structure and the regulatory framework. So now to contextualize this, by 2040, Eskom plans to reduce coal generation capacity from 39 gigawatts to 18 gigawatts. And the plan to do this is by ramping up renewable energy generation. We're currently sitting at under 1 gigawatt of renewable energy in South Africa, and the plan is to increase this to 32 gigawatts. Now, many of us on this webinar are playing key roles in this value chain around renewable energy generation. But I think the extent of this change is unprecedented, and it presents both an opportunity and a risk. And I have a saying that I always say, which is essentially that reward is a function of risk. And as developers, PPA providers, financiers that understand this value chain that we're discussing today, I believe we'll be able to lead in this market and really add value to businesses in South Africa. So to talk about the first aspect really is around this market structure and regulatory framework change. This is the liberalization and unbundling of Eskom. So briefly, the Electricity Regulation Amendment Act era came into effect last year in early 2024. And what it did was it separated Eskom's distinct units into generation, transmission, and distribution. What culminated from that was the Transmission Company of South Africa, the NTCSA, which really operated as this transmission system operator with effect from April 1st. So what this actually means really is that it's allowed power producers to compete on a level playing field regulated by NERSA, and it's enabled an open wholesale electricity market. Now, I'm going to come back to that term, open wholesale electricity market, because this is the key underpinning into some of the finance solutions that we're currently seeing in the market. Equally important is what we're seeing in terms of the infrastructure investment into the grid. So there's a plan to spend roughly about 390 billion rand over the next 10 years to commission 14,000 kilometers of transmission lines and about 170 substations. Now, the reason why this is important is going back to this open wholesale electricity market. This is not possible if we do not have the adequate grid capacity, both at a transmission and a distribution network. What this also has allowed for is what I'm referring to as the birth of wheeling. So now wheeling has been around as early as 2008. But what we're seeing here in the market currently is a bilateral contract between a generator and a consumer. And what this has predominantly been focused on are Eskom connected clients that are MB connected. But why this is important, going back to this open wholesale electricity market, is that we are now seeing the move, which is in some respects, in certain metros, there's a legislative framework which allows and permits this, is we're seeing that there's the ability to wheel intra-municipality, so within a municipality, from a generator that's Eskom connected to a customer that's within a municipality, so from Eskom to municipal. And I think if I talk to from a financing perspective, why this is important is that going back to this risk reward profile, what it means for financiers is that we can evacuate power should the off-taker be unwilling or unable to take that power. And this fundamentally changes the risk reward profile that we're seeing. Now, the SAP market, which is the Southern African Power Pool, really leverages what we're seeing currently in South Africa, but flexes this on a regional level. So 12 utilities, including Eskom, and this provides a regional platform and market for short-term energy trading, a day-ahead market, and more recently a focus on the intraday trading and balancing market. And what we heard earlier today from behind around the SIG stack, as well as Paul from Solar Boost, is that we are going to be seeing a very important shift as we move from monthly reconciliation of wheeling to a time of use conciliation. So there's going to be an excess and a deficit. And balancing using battery energy storage is going to be key in how we manage and apportion those risks, both from a generator and from a consumer of power. So my colleague Jason is going to talk about structures that we are seeing being implemented in behind the meter PPA solutions for different sectors. My view is that there's currently a silent consolidation of the financing houses in the market. So we saw a big entry of many players that were looking to finance renewable energy generation in the last year or two. And that really ranges from asset managers to funds that are focused on the 12B and 12BA tax allowances, as well as PPA providers that have been in the market previously. And my view is that within the next 12 to 18 months, we're going to see that number reduce from around about 20 to 2 or 3 players. So what does this actually mean now in terms of businesses in South Africa? So a South African business, what does this all mean? Open electricity market framework, wheeling, SAP. The liberalization means that businesses really are ushering the advent of choice. So no longer will businesses have to settle for a rand per kilowatt hour or kilo tariff or a monthly payment over the next 20 years. The conversation is shifting now. So what we are seeing is the conversations that we're seeing in the market are increasingly more around how do we increase your renewable energy penetration for a business over time. And there are 4 key things in this that we're seeing for South African businesses. So the first is the behind the meter installations will be supplemented by wheel power. There will be a diversification of energy sources, and we're seeing this currently, solar, wind, and battery energy storage, from either financier-owned generators or generators that are are owned through EPCs and then sold to these end user customers. The diversified energy supply also means that the take or pay requirements that we're currently seeing in the market will soften. So financiers and generators will be able to nominate where and to whom excess power is sold to. The second is operational resilience. What this open wholesale electricity market provides and allows for is a secondary market for electricity. That together with inter-municipality wheeling will ensure that businesses will have an ability to evacuate their power if they are unable to use it. But the other side of it from a owner of a business is that if a generator fails or is unable to produce power, they will be able to procure power from other sources. So it really manages their risk from a continuity perspective as a business. And the third thing we're seeing is bespoke energy contracts. So, we use this term often in industry, innovative, bespoke. But what does that actually mean, right? So if I use an example, so one of the clients that Fibon is working with is a plastic extrusion manufacturer. And we have a behind the meter installation that we're installing solar and battery. Now they are ramping up production in 2027. It's in terms of a long-term contract that they have with the EU. Now they will enter into an option with Fibon to buy power for that 16 to 18 months at the ramp up electricity requirement. And after that, they will ramp down again to its baseline need. So what that does is that if things have changed or circumstantial change in business, they will have the election not to exercise that option. And what this does is essentially it mitigates the risk to a business. It reduces the cycle that we spoke about earlier, this multi-year renewable energy generation decision or buying decision cycle, because now the tenor of the contracts are short. They are penalty free or nominal penalties that are applicable, and it really gives businesses in South Africa choice around how they manage and optimize their electricity consumption. The last thing we're seeing in the market is this consolidated utilities are being financed. So what conversation started really around 2014, 2013 around energy security, which then shifted into cost sensitivities and how to reduce the costs and OPEX. And now with the changing tariffs and the ability to utilize arbitrage, how to manage both cost and the availability of supply. We're seeing this now in terms of utilities, where the discussion and conversation is now broader than energy, and it's being broadened to water. It's been broadened to carbon. So REX has been in the market and conversations for many years, but we're seeing this now, particularly in the market, where there's a cross-collateralization of utility services. So, as an example, Fibon will finance an energy solution as well as a water solution, and we will monetize this with a carbon framework for a EPC or a business owner. So together, these items are shifting the narrative and the conversation, and it's empowering businesses. So they can transform what historically has been these energy challenges into real strategic advantages for their business. I think the next question, looking at many of the companies and people on this call is, so what does this mean for OEMs, equipment distributors, EPCs, and installers? So the first thing that we're seeing in the market is it broadens market access. So as a manufacturer, as a distributor of equipment or installer, an EPC, we have a South African consumer of power that now is working with the financier, such as Fibon and other players in the market. And there we are then looking at purchasing power from Mozambique, Zambia, and doing that through the SAP power pool, or through behind the meter installations that are utilized in other provinces in South Africa. So what this does is unlocks new territories and new customer segments for equipment distributors and EPCs to enter that market with the security of working with a South African financier that has a South African customer. And it mitigates a lot of the risk that's involved in that in terms of going into a new market. So the second thing we are seeing are, integrated solutions and opportunities. So what does that actually mean? I spoke about this from a business perspective as a South African business, but EPCs and installers can move beyond standalone solar or battery installs to turnkey energy and water packages, and we're seeing that this housing this umbrella under one package to a customer then means that there's a cross-selling for EPCs and installers, but as well as it opens up the spectrum of options for their customers. The third thing that we're seeing is the annuity streams of income for equipment distributors, EPCs and installers. So what we are seeing, for example, is that because where there's consolidation across the board, and this is what Fibon does, is we look at energy, we look at water, and we have the registered carbon project in the CNI space in South Africa. So what that effectively does is we have an EPC that goes into the market, and the conversation then is not about whether this is 7 Rand or 8 Rand per watt. Because then we assist the customer and the EPC, and we say, look, this is the 10-year annuity that we can give based on the carbon credits should we stack this into our bucket of a grouped carbon project. And then it becomes a very different conversation completely, because now we're paying the customer money and the EPC money is receiving income from that. So lastly, what we're seeing here is more value. And this is to the customers of OEMs, equipment distributors, EPCs, and installers. So what it does is it really helps you to stand out in a crowded market where there is downward pressure on costs, and it allows you to deepen these customer relationships by adding tangible and real value to them. So now, with that, I will hand over to my colleague Jason, who's going to explore and unpack some case studies on what we've discussed today. Thank you.
Yeah, thanks very much, Avesh. And we're looking forward to hearing what Jason has to say. And before we get on to the Q&A session. So over to you, Jason, if you can put on your presentation. And we look forward to hearing what you have to say, Jason.
Yeah, thank you. Thank you very much, Chris. Appreciate that. And thank you for everyone for joining us. It's always nice to connect with people in the industry. I was waiting for my presentation to come up for some other reason. Yeah, so as Avesh mentioned, we are, I think what we've seen over the last while is a significant change in the way solar is sold and the demand for solar. So, not so long ago, we had lots of load shedding, that all disappeared. And at that point, the economics for batteries kind of disappeared. And at that stage, the economics spoke to the mitigation of load shedding. Suddenly, we had no load shedding, and the economics of a lot of systems disappeared. And I think this created a little bit of flux in the market at that point. And I think EPCs, installers, funders had to go rethink and rejig this. And there's been a significant shift in battery storage strategy and how it's used. So without daily blackouts, had to look for alternative uses, and I think Paul touched on this. We've seen significant opportunity both in the tariff or energy arbitrage space and both in peak shaving. And I think these tools are generally able to deliver a significant or tangible return on investment, and then thus improving the case for battery storage. I think what's also driving battery storage outside of the sort of lack of load shedding at the moment, for want of a better phrase, is we've seen a significant decrease in the cost of storage. According to Bloomberg, we've seen just over a 40% reduction in the cost of storage between 2023 and 2024. This relates to the DC side of storage, so from your inverters to your battery storage and the other odds and ends that are used there. Generally driven by, I guess, the advancement in technology. I know Heinz spoke about SIG Energy. We've seen some really impressive results from SIG. Also seen economies of scale from the battery manufacturers, where they're able to produce a lot more, thus driving down price. And we've also seen a reduction in some of the raw material prices, which has also helped us reduce that, which has also helped the industry reduce the cost of storage significantly. So while we've had the cost of storage go down, we've also had the price of electricity go up significantly. According to Daily Investor, tariffs have increased by over 1,000% over the last 20 years. And Power Optimal reckons that between 2007 and 2022 alone, we saw a 637% increase in the cost of electricity. And I think as an industry, we in the short to medium term, we don't see this trend reversing. I think the expectation is still for above inflation increases. I think we're also going to see the nature of tariffs change. So we expect to see, I think this has already happened in some instances with some of the ESCOM tariffs. We've seen fixed costs increase. We've seen peak tariffs increasing at a higher rate versus your standard and off-peak tariffs. And then I think Paul also touched on that this we have seen the time of use periods shifting, or especially the peak rate sort of shift to the afternoon. So I think all this bodes relatively well for industry. We have two things going in our favor as far as optimizing battery storage. As I said, that's the decrease in the cost of the tech and the increase in the cost of electricity prices, which I think makes it a lot easier to make these battery projects work, not only from a cash point of view, but from a funded point of view. What we've also seen is that we've seen significant demand out of certain sectors within the solar space, and one of those that's really close to my heart is that's the agricultural sector. As far as funding is concerned, they have some significant complications, and one of them is generally farming is a relatively complex operation. Might not always seem like that, but on certain farms, the operations are relatively vast. The other thing we see is that energy usage is also relatively seasonal. So a lot of farmers only irrigate during a certain period, or they'll be harvesting during a certain period, or processing product during a certain period. And this has a significant impact on the ability to provide a power purchase agreement for this type of customer. The other thing is, farmers, due to their location, are generally susceptible to significant power outages, which also has quite an impact on production. So just to give an example, I've worked with a couple of table grape producers, and I think it's really important to understand the agricultural industry and to really understand your customer to be able to design a funded product that really works for them. So if we look at a table grape producer, for them, if they lose power during a packing season and the temperature in their packing room goes up, they lose a significant amount of money. Those grapes will not last as long. The quality of the grape will decrease, which means a significant financial loss. We also see, the continuity of supply during that period is really important for those reasons. Once they've packed, and once they've packed in sort of the late December, January sort of period, their power usage drops relatively significantly. So your standard cookie cutter PPA or funded product doesn't always necessarily work for this type of farmer. So it's up to funders to figure out how we do it. And we've looked at various options here, being a customized solution where we vary the tariff according to the season that the customer's in. We align we align the actual payment to the season that they're in. So if they're in a season where they're producing a lot of product, a lot of grapes, they'll generally have a higher tariff versus the lower tariff in their off season. So I think it's up to the funders to really be creative in how we look at it. I was chatting to another funding partner of ours, and the comment they made was that all the easy projects are gone. So it's up to us to really figure out how we fund these and how creative we can be in structuring funding that really works for the farm and delivers value to the enterprise. I think another sector that's often undersold to or underlooked at is the sectional title space. So whenever I drive through an area with lots of townhouse complexes, and you kind of look across the roofs, you see very few solar modules installed, and there's obviously a few reasons for that. But I think over the next while, there's going to be some significant cost drivers for sectional title schemes, and one of those is that we expect, or there really is a push from Eskom and from other of the energy supply utilities to start pushing their larger customers to go to a time of use tariff. I guess the challenge for sectional title developments is that, because of their load profile, being a domestic load profile, we see a significant peak and significant morning peak and afternoon peak, which then correlates to the peak tariffs that the utility will charge. We've seen winter tariffs in excess of 7 to 8 rand per kilowatt hour, which is going to be significantly more than the standard cost of energy at the moment. This does create some opportunities, I guess. The one is arbitrage, as we've spoken about, the ability to store cheap energy and discharge it during those peak periods. I think there's a definite opportunity there in complexes over the next while. Hopefully my crystal ball is right. Again, funders will need to be creative. It is a tough market in the sense that you're dealing with body corporates who you have to convince a lot of people, not just two or three directors of a business. You have to be aware of the legal environment. You have to understand the Sectional Titles Act to be sure that you don't overstep. But again, we've seen significant opportunity there. I think Paul's chatted to it. Hein also chatted to it. The event of artificial intelligence, I think, will also ensure that we see a significant optimization of the results in these particular projects. I think the third sector that we've seen some significant demand coming out of is the commercial and industrial sector, and this over time, I guess over the last few years, this has been dominated by grid-tied or grid-connected projects. And I think all of us are really familiar with grid-tied or grid-connected projects. Deliver really good financial results. They're reliable. We understand them well. We're able to model them really effectively. However, they only impact the active energy charges. And I think we're going to need to start taking a more holistic view on the other charges that are increasing. Demand charges, again, I think will be a significant driver of battery storage within these businesses. The obviously energy arbitrage as we see the cost of energy increasing, particularly in the peak tariffs. And I think it's going to be going back to those customers and figuring out how we can holistically reduce their cost of energy. I think that's that's going to continue driving the growth of obviously cash and funded solutions within these industries. The one thing I think the industry is struggling with to some degree is how we effectively model the returns or the battery returns. And Paul's right, it's really difficult to take a measurement now and install a battery solution and expect that battery solution to perform effectively over time. I think that's where funded or power purchase agreements really come into their own, where we're able to really manage those systems effectively and continually adjust them to make sure that the customer is still achieving a really good financial result. I think the other thing we also seen is as far as battery warranties are concerned, I think that one of the challenges the funding industry has had is that the length of time we've been able to fund batteries over just hasn't always allowed us to effectively produce a really good solution. So just to conclude, we as far as we're concerned, there's a massive opportunity in battery storage. It's becoming a strategic asset for energy cost management, and as funders, EPCs, and energy professionals, we must really adapt our go-to-market strategies, embrace and customize our funding models, and educate clients about arbitrage and peak shavings and the other benefits that we can derive from battery storage and funded products. Great, thank you very much. Chris, let me hand over to you. Thank you for your time.
Thank you, Jason, also to Avesh for your valuable insights from a company that is financing and driving the adoption of renewable energy in the commercial, industrial farming, sectional title space, the applications that you've highlighted. And that brings us to the end of our presentations. And I'd like to ask all of our presenters now to switch on their microphones and their cameras, because shortly we're going to go into this open Q&A session. But before we do, if I can just say that, the presenters today and the companies have been carefully chosen to kind of do an overview of where we are and the challenges that are currently faced in the solar PV and battery energy storage space. So we heard firstly from T-Good, who really presented on two areas, one being modular and containerized switchgear solutions, and balance of plant for probably larger scale industrial and even utility scale applications of solar PV and battery energy storage, the balance of plant, the substation, the switchgear, etc. for this. And then, of course, they looked a little bit closer at the switchgear requirements from basically 11 kV up to 132 kV, focusing on SF6-free switchgear, which obviously has safety and environmental benefits. So that was and then, of course, they presented on the Brunstock battery energy storage offering, which gives an example of the state of the art in containerized, larger scale battery energy storage applications. So really, you're talking about the industrial and utility sector there. After that, we went on to a presentation with Hein Herold. Hein, as you know, Herold's, his company, is a major importer and distributor of a wide range of electrical products, which include PV panels and inverters and battery storage. But in his case, mainly focusing at the residential and commercial, and maybe the smaller manufacturing, but also larger industrial applications too. But what I took away from this is the tremendous advancements in technology and modularity, providing increased flexibility, very again along with T-Good. The speed of deployment through modularity, factory-built assemblies, and the latest technologies, in this. So it was really interesting for me to see an emphasis on safety, things like built-in fire suppression equipment down to the rack level, down to the module level, where every module has its own built-in fire suppression system right where the problem lies, at the cell level. And that was interesting that this is now becoming mainstream. I mean, there are other manufacturers that do this, but there are many, many, many that don't have this built-in fire suppression. So we're kind of seeing this trend. And then they also touched on the trend of what they call arc fault detection and circuit interruption, which is a facility built into the inverter to detect arc faults on the DC side and to interrupt them, because interrupting a DC arc, it doesn't just go out on its own. You have to actually shut down the supply to create a current zero, and that extinguishes the arc. And there's a new IEC standard about DC arc fault detection and circuit interruption, but it's not yet mainstream in the residential and commercial space. There are manufacturers that do it, the top-end manufacturers, but it seems to me that this is going to become a mainstream requirement in the residential and commercial space for fire protection. So that was really interesting. And then we moved on to Solar Boost and TruePoint, who TruePoint looked really carefully about how they help clients, in the sector, take things forward and make things happen from a business level. And Solar Boost, obviously, with their AI technologies to what they call their 3M optimization: measure, manage, and maximize. I also call it measure, manage, and monetize. Because ultimately, it's about return on investment, and maximizing savings, as well as security of supply, and of course decarbonization. And then lastly, Fibon, and sorry Fibon for pronouncing it wrong at first, calling it Fibon or Fibon, but it's Fibon, I can see. But again, we're seeing solutions coming, identifying risk and looking at financing solutions that speed up this whole business of speed of deployment, because time is money. The quicker you can do it, the quicker you get the savings, the better the return on investment, the better the business case. And looking at different sectors, the challenges in different sectors and where things are going. So all in all, I think it was a really nice, well-balanced and rounded set of presentations. Thank you to the presenters. Now, we've had a lot of questions on this webinar, and I'm very grateful to our presenters who have together answered 60 of the questions. And there are only a few, and probably not many at all, of unanswered questions. So that's really great. It means that our presenters have engaged with the audience, answered many of their questions, and I'm going to be sharing with everybody a feedback report tomorrow with all the presentations and the video and the contact details of all the presenters, so that you can pose questions to them directly if there are any unanswered issues that you would like to put to the presenters, to get their feedback and input, and to expand perhaps on some of the answers that they've given in text form. But this has given a great opportunity, I think, to actually do what I call hands-up questions. And that is to ask you, the presenters, to put up your hands and ask your questions orally. so that we can get our presenters to answer your questions verbally. And that's quite nice because it gives us the opportunity to really engage with the audience in a way that is different to just the just the text questions and answers. So I'm going to ask all our participants, and we've got many hundreds that are on the webinar at the moment. And if any of you would like to ask a question, I would ask you to please put your hand up. I will see your question. I will see your hand up. I will then switch on your microphone and allow you to talk. And I see we have Paul Vermeulen with his hand up at the moment, and I'm allowing you to talk at the moment, Paul, so you can switch on your microphone and pose your question. Paul comes from City Power originally. He's retired and he's now a consultant. He's involved heavily in the battery energy storage area. So Paul, over to you for your question.
Thanks, Chris. Part of SAISA, we did a bit of a study, and it turns out that there was a huge investment in energy storage in the 23-24 tax year, in excess of 35 billion rand. And that kind of tells me that there's up to 6 gigawatt hours worth of energy storage in South Africa, and we've heard that the guys were looking for ways now to use that energy storage. So my question is anybody aware of anybody who's going around trying to aggregate all of those energy storage systems that exist already, and perhaps offer that either directly to Eskom or to the municipality as a demand response program? Is there anything happening there? Thank you.
Paul, I just want to say, watch this space, because I'm planning a webinar on virtual power plants. Aggregated, dispatchable solar PV and battery energy storage is one of the ways in which one can provide a virtual power plant. There are, of course, other ways like electric vehicles, which are dispatchable, connect to the grid, and there are large-scale demand market response. This shedding of load by smelters and things like that, which acts as a virtual power station. Ripple control with geysers, hot water is an energy storage means, and this can be a good way of, reducing demand, which is really a virtual power plant and that delivers megawatts as opposed to megawatts. Yeah. So Chris, there is a lot of opportunities out there, and I'd like to maybe put this to Hein, who's involved with inverters and battery storage.
This was actually
residential and commercial. Can you dispatch these resources on command from a control center to start generating into the grid? Get hundreds of consumers generating into the grid at a certain point, delivering a service to municipalities.
Yeah, so we actually were at an event yesterday that we hosted, and this was actually one of the big topics that was discussed, because we were in conversation with guys that are doing the rent-to-own type models that have thousands of these systems on their books. And the main thing about the aggregation of them is the way to control, or the way to aggregate them into a platform where you have got full control over them. So yes, I can tell you that there is currently advancements being made in that portion where a company that I know of is developing a device that would then plug into the various solar PV systems, whether it be residential, commercial, wherever it is, to aggregate that data into a central control system, and you as a user or as a owner of a system will then be able to offer up that portion of the energy into this platform. And then obviously their next step was, once they have aggregated a bunch of systems, then go to either the new, like Avesh said, how the various traders would come in to offer them either via wheeling, or then go into municipalities that are willing to take them. So In the old days, ripple control was a real way of them doing that. Now, because we've all got smart systems and all of that, it's really becoming a reality. So it's definitely something that's being looked at. I know a lot of people in the industry is currently trying to catch the head end of that space and developing the devices, because obviously you need to get the devices cost down to get them onto these systems so that you can control them. I mean, whether it be through API control or whether it be through an actual physical device that is connected, it is definitely something that is being developed at a quite rapid pace at the moment.
Thanks
So
very
just,
much, Hein, for those insights. Is there anybody else that want to come in there?
Yeah, Chris, we've got 2 proposals out to estates for a product we call Export Pro, which effectively does that. So I think, once you start exporting to municipalities, there's a little bit more complexity, but our kind of approach in the market is really to go after the estates. So export within that, and our product already does that. Effectively, it creates a distributed VPP of all the houses.
Yeah, I agree. I think there's a lot happening, as Heinz said, and I visited recently a Freedom One's plant here in Johannesburg. Really impressive, and every one of their batteries has got a gateway that can not only monitor that battery down to the cell level, voltage, temperature, current, charge, all of these things, but can also, send commands to the battery and the inverter. When you've got a smart battery, a smart inverter, and a communications gateway to each, you can start doing things like aggregation.
Manufacturers are all becoming VPP ready. So I know C Energy is also VPP ready, so it can automatically plug into any virtual power plant as well.
Yeah. And of course, the electric vehicle market, the
Yes.
vehicle to grid, it's all becoming a reality now. So I believe there's dramatic and exciting changes ahead in the electricity supply industry to optimize the network, optimize the grid, to avoid the need to spend 500 billion rand on networks if you can optimize it properly. I want to move on to another question, though, and that is from Ntokozo Radebe. Ntokozo, I'm allowing you to talk now. Please switch on your microphone and ask your question. Thank you.
Thank you so much, Mr. Chris. And thank you to the presenters. What I just wanted to ask is that there's a lot of research that is being done into the battery energy system being able to provide ancillary services and new technologies such as your grid forming inverters. How far are we in the context of South Africa to be able to implement these technologies?
Yeah, thank you for that really interesting question, Ntokozo. And I've been following, the question of grid forming inverters. We had grid following inverters, we have grid forming inverters, and then we have a hybrid inverter, which is both a grid following and grid forming. And most of the grid forming inverters at the smaller systems were to generate the grid when the mains was not on. But you also have grid forming inverters that operate while the mains is on, and they provide grid services like voltage control, frequency control, short circuit, managing system disturbances, synthetic inertia, all kinds of grid services. So I want to ask, is there anybody on our panel that knows more about where things are with grid forming inverters in South Africa? And I know that the major inverter companies are doing a lot of work in this field. Anybody want to take this question up? Okay, look, it's a difficult question. It's the state of the art, and I think we should note that question and come back to it. If we have people on our panels that can answer it. But if anybody wants to come in
the
there,
technology is available. That I can say the technology is available. We are currently dispatching one project at the moment with that in a rural area, but or in a very outlying area. But I think this is something that's a little bit much deeper discussion than just a product overview.
Yeah, I agree, Hein. When you're talking about off-grid microgrids that are not connected to the grid, remote areas that are completely off the grid and need a microgrid, there you need a grid forming inverter, and they are being done. But as I mentioned, there's also the case where you have a grid forming inverter providing grid services through a battery energy storage plant, through a grid forming inverter providing grid service ancillary services. That's
We have a
another
case like that
very
in the Northern
big
Cape
and
currently.
complex technical subject, which I don't think we can go into here. I'd like to now move to Clyde Mallinson. Clyde, I'm allowing you to talk. Please keep your question as short as possible because we are coming towards the end of this webinar. Over to you, Clyde. Can you switch on your microphone? I'm allowing you to talk now.
Right, I've done so. Thanks, Chris. I saw with an element of surprise and shock that in two recent presentations that Eskom made, I think to the Parliamentary Climate Commission as well as to the Parliamentary Subcommittee on Energy, that they grouped battery energy storage systems as being something out there that are still very expensive, and they put them together with small modular reactors and carbon capture and sequestration. They grouped the three together and said these are expensive technologies that we kind of, and I just would like a comment on the grouping of battery energy storage, first of all, as being expensive, and secondly, putting it in the same category as small modular reactors and carbon capture and sequestration, because I nearly fell off my chair when I saw that particular section of the presentation. And I just thought yeah, any comments on that without putting a target on your back?
Yeah, who's going to handle this one? Who wants to handle this one? I also find it very funny. I think they haven't woken up yet. Over to you,
I don't
Hein.
want to laugh about it, but we've got all of the information showing you the reduction in battery energy storage pricing. I think one of my major Bianca spoke about risks, in a business. I think one of our biggest risk is that when we bring the product in, that the price does not reduce beyond control by the time it needs to move out. So we are seeing massive reduction in battery energy storage pricing. I think Anton can also attest to this.
I agree 100% with you.
It's the biggest risk for us is actually to carry batteries in stock for customers because of the worrying the same thing that happened to us with panels. We had a massive amount of panels in stock, and literally overnight we saw a 40 to 50% reduction come in. So, batteries decreasing steadily, but it will continue to decrease because as the mass adoption happens, the price will come down. That's guaranteed.
I agree, and I think we can all agree, that's a little bit of nonsense out there, misinformation. To lump it together with carbon capture and storage and small modular reactors, which haven't even been developed or commercialized yet, is just absurd. Okay, let's move on to, now I hope I'm going to pronounce this right, Jay Hochan Ramango. I am switching on your microphone. Just 1 second while I allow you to talk. I think, is your microphone? Yes, your microphone is on,
Yes,
Jay.
my
Fire
mic
away.
is on. Yes, thanks for the opportunity. My question is with regards to the future of BES and PV systems in South Africa. Should load shedding be a thing of the past from now on? What other key functionalities other than arbitrage and peak shaving will BES systems have? What is the need for us to further improve that technology?
Let's chuck this question at Anton for a start, and then also at Paul. Anton, over to you.
Well, the battery energy storage systems, in the CNI residential will always ensure businesses to be operational, always to have electricity and be operational and be able to produce products. I think that's one of the biggest advantages to have battery energy storage in the CNI industry.
Are we going to be seeing further price reductions? Are we going to see, a greater energy densities? In other words, more power packed into a container. You have alluded to that, Anton. You talked about some future products which are going to significantly increase the amount of capacity in a container. What's the sort of timeline for that sort of thing?
Well, that's already starting. Like I said, already in 2000 or this year, some of the manufacturers is manufacturing 500 amp hour up to more than 1000 amp hour cells. Okay, so now you can see the density of how compact it's getting. Okay, and your base containers is just getting bigger and bigger. But it's important to note that with the bigger cells, the increase in your batteries is weight is quite significant. Okay, and for logistical purposes and handling purposes, that's important to note. On utility scale based projects, to maintain that batteries, and remove a battery, you need a forklift, because we're talking of 685 kilograms and even more for one battery. And to remove a battery or replace a battery, you need a forklift. So it's not an easy task. So yeah, there is a big trend in new technologies, larger energy density, bigger cells. And I've seen a couple of them physically, and it is quite a difference between what we have today and what we have in the residential and CNI space, and what they are doing in the utility space. It's a huge difference.
Thanks, Paul. Moving away from the actual battery, etc. What do you see, as technology improvements that can really optimize the performance? I'm talking about a futuristic look at the integration of ICT and artificial intelligence and power to really deliver, advanced solutions.
I mean, I think the first thing is what we're also benefiting from is a lot of the R&D investments going into EVs, right? There's a lot of crossover between the batteries that we're using in EV batteries, and you're looking at upwards of, there's hundreds of billions of dollars of R&D going into it. So that industry is going to shift massively. It's quite hard to, I don't have a crystal ball, and I think actually Han might know more than I do, to be frank. So maybe he's better placed to, because he's got a lot more kind of contact with OEMs. Han, I don't know if you want to chip in here.
Look, the main thing is PV is becoming cheaper and the energy from the sun is free. So if you look at that, that sunlight is only during daytime. So we're going to need a place to store them. So, it ultimately not just arbitrage and peak load shaving, but also the storage of the energy for consumption is going to be very, very important, because as PV adoption grows, you're going to need more of that. That's why Australia has now added this massive battery rebate, because they started out by deploying a whole lot of PV, but PV is intermittent, and wind is intermittent. So you need to find a place to put the energy that was produced during the day, because otherwise it just gets throttled back. So right now they've got a massive battery rebate where they are encouraging users to install batteries on residential and CNI, where the government's actually funding a large portion of that so that they can store the excess PV that they have, because in Australia they have quite a lot of excess PV during the hot days that they need to store and not be reliant on black and brown coal in Australia that much. So that is definitely where battery is going to, why it will still continue. And it's not just a load shedding solution, it's actually a storage or free energy solution.
Inside. Look, we got two more hands up, and then I'm going to call it a day. Let's move to David Serfontein. David is a regular participant on our webinars. David, I have switched on, allowed you to talk. Please switch on your mic and ask your question.
Chris, yes, it latches on to the previous comment about the negative view of Eskom on batteries. I want to ask, what do you see the policy from government? Because we have all these unbundling of Eskom that creates all these opportunities, and then we have ministers, the previous Minister of Energy actively derided, renewables in his speeches, and he's still an active player, and the other ministers are all, saying wonderful things about new small modular reactors, which it's my field studying it, and I just don't see the cost of those coming down fast enough to really be cheap enough to do. So if you compare the policy that we see in South Africa to the policy that we see in South Australia, where they say in South Australia, we know we've got to go renewables, so we've got all policies that drive this. In South Africa, the political thing is maybe we don't want to go there. And if you then, but we are going there, but we don't want to do it. So what's going to happen? And if you look at the municipal space, the small municipalities in South Africa, you can't even feed your solar back into the grid at this stage. So where do you see between the rhetoric and what's actually going to happen? Where is government actually going to take us in the next 5 or 10 years with this policy?
Thanks, David. Yeah, you've touched on important points, Avesh spent some time talking about, where we are with the restructuring and things like this. And I must tell you, I believe there is huge uncertainty developing. He talked about the South African wholesale market, talked about wheeling and trading and these things, and yet we are seeing a messaging coming not necessarily from the politicians, but from within Eskom, is taking a big step backwards. People talk about what is known as malicious compliance. In other words, they talk the talk about restructuring and reform, but behind the scenes, they were doing everything possible to slow it down and stuff it in the eye. You see this with energy, with Eskom, for example, opposing trading licenses. You see it with them not allowing virtual wheeling by traders on the new virtual wheeling platform. You see it in the NTCSA, the National Transmission Company, not being properly independent of Eskom, but highly conflicted between Eskom, which is owning the generation business, and it is directly controlling the NTCSA, which means that it's not really independent. It's not really on level playing field, certainly not yet. And there's a growing sense of resistance towards reform. So I would say there's a lot of risk still out there, plenty of risk. When Avesh was talking about the risk and reward, but you know what? The more risks there are, the greater the opportunities are. For example, for behind the meter solutions, I think South Africa has got so much more potential for behind the meter solutions. If you look at the penetration of countries like Australia, we've got a long, long way to go with lots of opportunities. And the more problems there are on the grid, the more grid constraints there are, the more opportunities there are for behind the meter solutions. So with these risks come rewards, and risks can bring opportunities. When there's a problem, there's an opportunity. So I'm going to move on. I know I want to take a last question. And Nolan, I'm sorry, I'm not going to be able to take your question, but I'm going to go to Richard Santos. I'm allowing you to talk, Richard. So switch on your mic, ask your question. Thank you. Are you there, Richard? Please switch on your microphone, Richard. Otherwise, we're going to take a last question from somebody else. Okay, look, it looks like Richard is not there, although his hand is up, but he hasn't switched on his microphone. So I'm going to look. I think the other speaker.
No, I'm here. Sorry,
Are
apology.
you there? Thank you, Richard. You're the last questioner.
Okay, I just want to ask a question based on the disposal of the solar and the battery during the end of its life, because I suspect if there's no procedure for disposal, we'll have a problem in 20 to 30 years to come. I want to be clear on that.
Good point. Yeah, Jason, why don't you handle this? I know you're in the CNI space. What are you doing to help facilitate disposal of solar panels and the batteries? And what is the future there? Is this a problem or is it not a problem?
Yeah, probably not a problem yet, but I definitely think it's going to be a problem in the future. So we have started looking at it, and I believe there are one or two companies that are involved in this space and are looking at the recycling of solar modules in particular. We haven't looked at batteries yet, but I presume that will come with time, I would imagine. But yeah, I think there's a definite opportunity in that space for recyclers to get involved to dispose of these products as they reach end of life.
Jason,
anybody else want to come in here on this? Yes, Simon.
Department of Forestry, Fisheries and Environment has published legislation that any producer, it's called the extended producer responsibility. So any producer or importer of a product is responsible for the disposal of that product at end of life. So there's various entities, non-profit entities in South Africa, as they have to be NPOs, like Circular Energy and ERA. So you as a producer or an importer, which you then also local producer or importer, then needs to join one of these PROs. It's called a Producer Responsibility Organization. We then pay on any volume imported. So per weight, there's a levy that we pay to them, and then they have the responsibility of disposal of that. So if you were to buy any solar panels from a Harold's branch, and in 10 years from now or 5 years, or let's say you've got hail damage in a year from now, and you've got an insurance claim, but you need to dispose of those, you can then just log the collection on Circular Energy's website. They will then come and collect and dispose and recycle that product and make sure it does not end up in a landfill. So this is law, and it is legislation that we all, the responsible manufacturers and producers, do pay these levies to them. And it's a circular economy. So it's basically all of the industries, whether it's from packaging to tires to everything, they're all part of the same, Waste Management Act. And in this way, all of that gets taken care of by a company that is managing all of this.
Thanks, Hein. I think we're going to call it a day now. And I just want to say it's been a great privilege having you presenters on the panel. You've answered a huge number of questions, in the text form. You've answered a number, verbally. And I think, I'm very proud that you have joined our webinar, both as presenters and also the audience. I want to thank, first of all, these companies that have supported us, TruePoint, Solar Boost, the Heralds Group, Brunstock, T Good, and Fibon. Really, it's been great having you on board, supporting this and providing such insightful presentations. To the audience, thank you so much for your attendance, for your participation, and I hope it's been useful and interesting. It certainly has been to me. And I want to ask everybody to watch this space for our next webinar coming up on the 6th of August, and it's really to do with with electric vehicles and how we can move to become a major destination for electric vehicles, using Norway as a case study. Of course, things are very different in Norway from South Africa, but we can learn from what other countries have done, and we can also adapt what they have done to suit what we are doing in South Africa. And it'll be really interesting to hear that. And it kind of flows on from this, because battery energy storage is the heart of an electric vehicle. And then the next webinar will be on virtual power plants, which is also kind of a follow on from this. We've talked a little bit about virtual power plants and how the different technologies, including battery energy storage, solar PV, electric vehicles, geyser control, aggregation of distributed energy resources can all help to optimize the network and the grid, reduce the need for new generation capacity, reduce the need for upgrading of transmission lines if we can manage demand better, reduce the peaks, fill the troughs, and get better utilization of the existing grid and existing network. These are opportunities for South Africa that come at least cost. And we should be looking at these very, very seriously, and we will be doing so in future. So lots to come still, and thank you for your participation today, presenters as well as participants and attendees today, and we look forward to seeing you again on our next webinar. Au revoir.